Hi, my name is Anya, and I was working on this challenge together with Romanos and Dejan, and we were analyzing the graphs for Bill.com company. So what we got as input was very interesting. We got this big graph, and our task was to determine whether an edge exists between two nodes, and we were supposed to learn something from the graph that we got in the first place. However, the graph at first looked very confusing. So what we did at first was try to visualize the network with Jeffy package. So we first visualized the network and we colored the nodes by page rank. And we also decided to the size of the node to be the degree of the node. So we can see that there are many nodes that belong to the page type 2, which means that page type 2 is probably very important and contains nodes of high degree. Then we realized by looking at the degree distribution that this network is scale free and that it has a power rank degree distribution, which then we then continued to further explore what do the page types mean. And we found that the page types basically give us 4 hubs. This is a slightly different visualization. And then we further visualized and we saw that the 4 hubs belong to all 4 big hubs colored here by their degree belong to the page type 2. We then found that the page type corresponds to modularity. And then we found that there is an extra important node that belongs to the page type 3, from the page type 3, not page type 2, the green one here, that's important by its page rank when we analyze the page rank. Finally, we were left with some questions. What do these important nodes mean? Will the two edges be will the two nodes be connected if they are if they have certain features, and what do these features mean? How to featureize the nodes, what learning architecture to use, and what are the best predictions that we can get? So we decided to featureize the nodes in 3 different ways, using the page type only, which seems like a good way to featureize them from the visualizations that we have before, using the doc2vec methodology, and using the glove embeddings, which kind of learn from the data as well. And then we decided to go with 3 different architectures, the basic GNN, the advanced GNN with slightly attention-based model, and the simple MLP multi-layer perceptron. What we saw was that really there is importance in these words. So using the page type only did not help. We needed to use the words, and using and embedding the words with glove really helped. So that was one important finding. Another important finding that we have is that using GNNs really didn't help a lot, and using basic MLPs gave us a higher performance than using GNNs, basic or advanced. And in terms of future work, what we want to do is more data analysis to analyze what these words mean and what these features really are, because we figure that they are important. On the other hand, we want to find a graph architecture that would actually improve this performance, because we think that the graph structure does matter, and it's strange that MLPs perform better than other graph models. And finally, in terms of deployment, we would like to deploy this as a server and be able to give recommendations to new users that come into the network on the basis of the previous network that we have. With this, we had so much fun with this challenge, and thank you for organizing this competition.